Naming compounds. So when you're looking at the formula of the compound that you need to name, you need to look and see if it has a metal. If it has a metal, so it'll be right there at the beginning, and if that very first element is a metal, then you're going to name it the following way. So you're first going to use the oxidation number in the name. So you'll write the name of the metal and then the oxidation number, and you will write that oxidation number in Roman numerals. The only exception is some of the metals only have one oxidation number, and because of that, it's a little bit overkill to tell everybody what the oxidation number is. And so your group 1A and 2A metals, they only have an oxidation number of +1 or a +2. Respectively. And then some other elements like zinc, cadmium, aluminum, silver, gallium, they only have one oxidation number 2. So you don't need to say that zinc is a +2 because everybody already knows it. So that's the first thing. Write the name of the metal and then its oxidation number in Roman numerals right after it. So number 2, you're going to name the second element. You'll drop the ending and you'll put the ending as IDE because it's an anion, the name changes a little bit. Or if there's a polyatomic ion, it's even easier. All you have to do is write the name of the polyatomic ion. So let's go through a lot of examples so you can get used to it. So looking at this first one, we have CuCl. So Cu is the element copper. So I am going to use this naming system. So we're going to start off with writing the name of copper, and then I need to put the charge of the copper. Copper can be a +1 or a +2. Which one do we have here? We need to play detective to figure it out. We're going to put its charge in little parentheses right there, right after the name. So what is copper bonded with? So it's bonded with a chlorine. What do we know about chlorine? We know that chlorine has a -1 charge. Well, if chlorine has a -1 charge and there's only one copper with it, which one of the oxidation numbers does copper have? And that would be copper would have a +1 oxidation number. So I put that this is a copper 1 compound, meaning that copper has a charge of +1. So the charge of the metal always goes in the name. Okay, so copper 1. Now I just need to finish it. So the second element is chlorine. So again, I'm going to drop the ending and add IDE. So this is copper 1 chloride. Let's look at the next one. So this is also a copper chloride, but which copper chloride is it? So I'm first going to write the name of the metal, COPPER, and then I know I have to put the charge after it. Let's play detective. So here I have 2 chlorines. So that means each one of them is a Cl minus. So 2 Cl minuses gives me a charge of -2. So what does my copper ion have to be? It has to be a +2. So I put the 2 in the name there. So copper 2, and then I write the rest of it. It's chlorine, but I drop the ending and write IDE. So these are the 2 copper chloride compounds that can be formed. So we have copper 1 and we have copper 2. That charge on the metal is so important to put into the name, because if you just said copper chloride, you wouldn't know which one you have, because copper can form more than one oxidation number. It is a transition metal. You can look on your periodic table, the white one that I gave you at the beginning of the year, and you can see on copper that those 2 oxidation numbers, that you can have a 1 or you can have a 2. So very, very important that when you're naming it, that you put it in the name. Let's look at this next one. So we have KCl. So potassium has a charge of +1 and chlorine has a charge of -1. And that's how it got put together. How do I name this? I write the name of the metal, and then I write the name of the anion. Now notice this one's a little bit different. Potassium can only be a +1. There's no other oxidation numbers. And so because of that, you don't have to put that in the name. So most of the metals do have their oxidation number in parentheses right after the name of the metal. except for if you have a group 1 or group 2 metals. So you should always plan on putting the oxidation number in unless it's one of these exceptions. Okay, let's do a few more so that you can get used to this naming. So the first thing I need to look and see is, does it have a metal? And this first one we have NiO, it does have a metal. Nickel is a metal. So I'm going to write the name of the metal, and then I'm going to put parentheses after it, and I need to figure out what is the oxidation number of the metal. So oxygen has an oxidation number of a -2. So nickel is in a 1-to-1 ratio with it, so that means nickel must have a charge of +2. And so that is what I put in the name. So this is a nickel 2 compound. So I write the second name of the element next. So it's oxygen, drop the ending, and write IDE. And just drop what makes sense. So oxyide sounds funny, so I can't even say it. So we would write it oxide. That sounds better. So whatever sounds better is usually right. So just say it out loud, and if it sounds good, then you're right, okay? So you end up dropping most of the ending of that name. So let's look at the next one. So we have iron, and I'm going to go ahead and just name the second compound. This is bromide. And iron can have multiple oxidation numbers. It's a transition metal, so we have to play detective to figure which one it is. So bromine has a charge of -1, and I have 3 of them, so that gives me a charge of -3. So that means iron must be a +3. So I put 3 in parentheses. So this is iron 3 bromide. Let's do the next one. So first of all, does it have a metal? Yes, it does. Sodium. Now sodium is one of those exceptions that I don't have to put the oxidation number because sodium is always a +1. But I have something a little bit different going on here. I have 2 other elements, not just one. This is the polyatomic ion nitrate, so NO3-. So all I need to do as far as naming goes, if there's a polyatomic ion, is you just need to put down the name. So this is sodium nitrate. So if you see 3 elements, know that one of those in the compound is a polyatomic ion. Okay, let's do the last one. So we have FeNO3, and there's 3 of them. So I know that's a nitrate. All I have to do is write nitrate. And I do need to name the metal, so it's iron. And iron, we need to figure out which oxidation number it is. So let's look and see what we have. So nitrate is a -1, and I do have 3 of them for a total of -3. So to cancel out all the nitrates, iron would have to be a +3. So I put iron 3 nitrate. So the naming is a little bit easier for polyatomic ions if you know the polyatomic ions. So learn those as quick as you can, and then you'll have an easier time. All right, let's go and do the opposite. So let's take the name and then write the formula. So it's very important when you are writing formulas to use oxidation numbers. And this is for if there's metals. If you have a metal, and it will be the very first word of the compound, you need to use oxidation numbers. So let's take our first one. We have potassium sulfide. So we're going to first write the symbol for potassium. And I know its charge, it's in the first family, so it's a +1. Now let's look at sulfide. So sulfide is sulfur. So looking at sulfur on the periodic table, its oxidation number is a -2 because it is in the oxygen family. Can I just put these 2 ions together? No, you can't, because they need to cancel out. I need to have 2 potassiums. That will give me a charge of +2 that will cancel out the sulfide of a -2. So I write the formula K2S. Let's look at this next one. So we have titanium 3 chloride. So titanium can have multiple oxidation numbers, but look, they tell us what the oxidation number is. It's a +3. So the answer is right there. I don't even have to look on my periodic table. So I know this is a titanium with a +3. And then chloride. Chloride is chlorine. So chlorine is a halogen. Halogens have a -1 oxidation number. Can I just put these two together, a +3 and a -1? No, I have to have them cancel out. So I'm going to need 3 chlorines. That gives me a charge of a -3. So I will write this as TiCl3. So notice that this oxidation number does not tell us how many titaniums there are. It tells us what the charge of the titanium is. So we have TiCl3. Let's go to the next one. So we have zinc. So zinc is one of those metals that only has one oxidation number. So that's why they don't say zinc 2 bromide. Zinc is always a +2. It's in that 2B family. So it would be a +2. And then bromine is a -1. It's a halogen. I cannot just put these together. I have to have 2 bromines. And so I will write the formula ZnBr2. All right, so what happens if you have a compound that doesn't have any metals? Well, this is actually a really easy naming system. You're going to use Greek prefixes. So you're first going to name the cation, and then you're going to name the second element, the anion, and you're going to say the ending ends in IDE. So you'll drop the ending and put IDE. And you have to use a prefix to tell how many you have. And so here are your prefixes. So if you only have one of the element, you can put the name mono, but that's rarely used. Usually you just put the name, and that just counts as one. If you have 2 of them, you say di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 is nona, and 10 is deca. So you're first going to just make sure there's no metals, because if there's metals, you have to use that other naming system that we already talked about. So let's look at this first one. So I have nitrogen, and then I have oxygen. Now because oxygen came last, we're going to drop the ending and add IDE. So this is nitrogen oxide. And I don't have to say how many I have of them because just writing their names says I have 1. So I have 1 nitrogen and 1 oxygen, and so I'm done. So nitrogen oxide. Let's look at the next one. So this is also a nitrogen oxide. Let's put how many you have. So it's just a counting system. So I have 2 nitrogens, so I would say dinitrogen. And then I have 5 oxygens, so I would say pentaoxide. And if pentoxide sounds better, that's just fine. I would accept either one, okay? Let's do the next one. So this one is carbon. I only have 1 carbon, and it's an oxide. And this is one of the ones where you do use the prefix mono. So again, it's very, very rare, but this is something that you have heard about. So carbon monoxide, just CO. Let's do the next one. This one is also a carbon oxide, but I have 2 oxides. So I'm going to say it's carbon dioxide, CO2. All right, let's go backwards. So we have sulfur, we have dioxide. As soon as you see those prefixes, you know the number. So you just write what they tell you to write. So sulfur, there's just 1. Dioxide means there's 2. So this is a very simple naming system. Look at my prefixes here. I know for sure there's no metals because it's named this way. So hexa, so that would be 6 sulfurs, and dioxide, O2. Carbon, so just 1 carbon because they don't tell me any prefixes. And tetra means 4, so Cl4. So CCl4. Di and octa, we would have 2 phosphori, and we would have 8 oxygens. So very, very simple. If you have no metals, you cannot name compounds that have metals this way. It is wrong. You have to use oxidation numbers if there's metals. All right, so let's practice. So stop the video and see if you can go through these. Okay, we're back. So let's look at our first one. So carbon tetrabromide, that tetra gives me a clue. And I can look up that carbon is not a metal and bromine is not a metal. So I just write how many they tell me to write. So CBr4. All right, let's look at this next one, nickel 2 oxide. Remember, this is an oxidation number referring back to the metal. I have to use oxidation numbers. I have to do a little bit of scratch work before I put it together. So this is nickel with a +2. Oxygen has a -2. So I can just stick this together, NiO. I have to do it in 2 steps, but I have to use those oxidation numbers. Let's do the next one. Now we're naming. So I have, my first one is calcium. Is it a metal? Yes, it is. So do I need to use oxidation numbers? And the answer is no, because it's an alkaline earth metal. And alkaline earth metals are always a +2. So I do not have to tell people that it is a +2 because it's always a +2. So this is calcium. Now look, this is a polyatomic ion. So if you, again, see that there's 3 elements, you look to see where the polyatomic ion is. So this is calcium carbonate. And I just write the polyatomic ion name down. I don't have to change the ending or do anything. So calcium carbonate, I'm done. Let's look at this next one. So I have iron. Is it a metal? Yes. And it is a transition metal, so it's going to have the little oxidation number in parentheses. And then it's going to end in oxide. So we are going to have to play detective, because which iron oxide is it? So oxygen. Oxygen has a -2, and I have 3 of them for a charge of -6. Iron right here, therefore, should total a +6. And because I have 2 of them, I can divide by 2 and I get a +3. And that is what goes in these parentheses. So you don't put all of the iron in, you just put in that there's like there was 1. Okay, so even though it says Fe2, I say each one of those irons is a +3. So this is iron 3 oxide, or rust. So this is the chemical formula for common rust. Let's do this next one. Are there metals? No, they're not. And so because of this, I can use the Greek naming system. So I just put down how many I have. So this is phosphorus dioxide. So again, it's very, very important you pay attention. If there's metals, you use oxidation numbers. If there are no metals, then you just use the di-tri system. All right, I'm going to do some more practice, but if you think you got it, you can just stop the tape. Let's go through and name each of these. So this is a metal. This is calcium. Calcium, and then this is bromide. Because it's a metal, I have to use oxidation numbers, but calcium is always a +2, so I don't have to use parentheses. Let's do the next one. Is there a metal? Yes, there is. This is cobalt oxide. So cobalt is not one of those exceptions. I need to play detective to figure out what the charge is. Oxygen's a -2. That means cobalt must be a +2. So cobalt 2 oxide. All right, is there a metal? Yes, it's cobalt again. And it ends in iodine. So drop the ending at IDE, so iodide, that is correct. We need to play detective. How many iodines do we have? We have 3. Each one is a -1. So that gives us a total charge of -3. That means my cobalt must be a +3. So this is cobalt 3 oxide. Our last one, is there a metal? No, there is not. And so dioxygen difluoride. So drop that ending on the second element and add IDE. Here's some more examples. So is there a metal? No, there isn't. So I just name each one. Hydrogen, and then drop the ending of the second one, chloride. And there's just one of each. And so I usually don't write that mono. Is there a metal? Yes. calcium chloride. There are no parentheses in this one because calcium is always a +1. Is there a metal? Yes. So iron, and iron can be a +2 or +3, so we need to play detective and figure out which one it is. So iron something bromide. I have 2 bromines, so all my bromines here are a -2. That means my iron must be a +2. Is there a metal? Yes, but it is sodium. Sodium is always a +1, so I don't have to put the oxidation number. And then this is the polyatomic ion sulfate. Is there a metal? Yes, so just write the metal. And aluminum always has a +3, so I don't have to tell people. And see all those parentheses? That means it's a polyatomic ion. So I just write the name of the polyatomic ion. And I'm done. Aluminum nitrate. Is there a metal? No. So I use the Greek system. So only one chlorine. And my second element is fluorine. So drop the ending and put "ide." So this is fluoride, and I have 5 of that. So that would be pentafluoride. So chlorine pentafluoride. So here is a periodic table that just shows those exceptions, the ones that do not need the little parentheses in the name. So again, we have group 1 is always a +1, so we don't have to tell people. Group 2 is always a +2. And then these here in the middle, silver is always a +1. Zinc and cadmium are always a +2. And aluminum and gallium are always a +3. So we don't have to tell people what the charge is. But you can see the majority of the metals that are in pink, you do have to put them in parentheses. So I always assume that there's parentheses unless it's one of these exceptions. So the first 2 metals families, and then silver and zinc and aluminum are very, very common. And notice they have charges of +1, +2, +3. Want to hear a joke about nitrogen oxide? No. All right, let's do some more practice with taking the name and then writing the formula. And for this, you need to use oxidation numbers if you have a metal in the formula. So don't just try to put it together using the symbols of the elements and the polyatomic ions. You have to use oxidation numbers. Let's look at the first one here. We have calcium oxide. Calcium is always a +2. It's an alkaline earth metal. Iodide is a -1. It's a halogen. There, we would have to have 2 iodides to give us a -2 to cancel out that calcium. So remember, when you put these together, you have to make a neutral compound. So our answer is CaI2. Notice that calcium doesn't have the little parentheses that tells the oxidation number, and that's because calcium is always a +2. Let's look at the next one, sulfur hexafluoride. That hexa is a big clue here that I have nonmetals that are bonded together and making a molecule. So all I have to do is write how many they tell me to write. So I have SF6. Next, sodium is a metal. It's a Na+. Sulfate, whenever it ends in 8, that is a clue it's a polyatomic ion. So hopefully you have that memorized, or you can look it up. Notice that the -2 and the +1 don't cancel. I am going to have 2 of the sodium, so Na2SO4 would be the final compound. With just one polyatomic ion, you don't need parentheses, so that's why it just says SO4. Nickel 2, remember, anytime there's parentheses, it refers to the metal. So this is nickel with a +2 charge. Chloride is a halogen, so it's a -1. I do have to have 2 chlorides to cancel out that nickel, so NiCl2. Now we come to antimony 5 oxide. So that is a metal. It's actually a metalloid, but it is acting as a metal in this case. So we put a 5+ on it, and then oxide is a -2. How do we put that together? Well, I can say how many SBs do I need? 2. Or I can say how many oxygens do I need? 5. And that's one way to do it, and that would give you the right answer. Another way to look at it is to take all the oxidation numbers up to 10. So if I have antimony 5 plus and oxide 2 minus, then I know that I would have to bring this up to a plus 10 and this is up to a minus 10. And so we would multiply this one by 5 and multiply this one by 2. So Sb2O5. Next one, sulfur trioxide, no metals. And there's a Greek prefix there. So just write how many they tell us. So these really are kind of easy because if you just pay attention to what the prefixes mean, then you can write what the formulas are. And the last one, sulfur tetrafluoride, again, there's that prefix. So write how many they tell you to write. So SF4.